Good morning everyone. So we had done till question number 12. Now we will do question number 14. So here it says an iron block is in the form of cylinder. So there is one iron block which is in the form of cylinder whose diameter means this length is 0.5 meter and its length, okay, its length is 3.5 meter. Next it's saying this block is to be rolled into the form of a bar having a square section of side 25 centimeter. So this should be transformed to a bar, okay, getting it? So this has to be converted to a bar whose this cross section, it's a square, okay, it's a square and its side is 25 centimeter. They want you to find the length of that bar. So here you should note one thing. Once you have converted this cylinder to a bar, only shape wise it has changed, okay, but volume wise it's same. Volume of this and this bar will be same, though shape has changed. So that concept has to be used, that volume is not changing, volume is remaining same, only shape has changed, okay. So you know what is the formula for volume of cylinder, pi r square h, and you know what would be volume, what is the formula for what is the formula for this, okay, it is length into breadth into height, okay. So let us see. So here question number 14, this is your cylinder whose diameter is given how much, 0.5 meter. If diameter is 0.5 meter, then radius will be half of this. So r will be 0.5 meter divided by 2. So you will get 0.25 meter. And in centimeter, if you want to change this into centimeter, you have to multiply by 100. So this will become 25 centimeter. Clear? Now why I am writing it in centimeter? Because here for the bar they have given these values in centimeter. Now height is 3.5 meter. If you want to convert this into centimeter, this will become, you have to multiply by 100, so you will get 350 centimeter. Clear? And for the bar, okay, your this cross section is a square, so that's why 25 centimeter. Length is not known to us, okay. So let us see solution. Note volume of the cylinder equal to volume of the bar. Now volume of the cylinder is given by pi r square h, and volume of this bar will be length, breadth and height, okay. So since I have to use height for both the cylinder as well as bar. So let me denote this h by 1 h1 and this one by h2. So pi r square h1, okay, where h1 is the height of cylinder, and here length into breadth into height h2. Clear? So volume will remain same. Now substitute the values. For pi you have to put 22 by 7, r 25 centimeter, so 25 whole square, h1 is 350 centimeter, length we don't know for the bar, breadth is 25 and height is also 25. So here 22, see over here, 7 1 ja and here 5 ja. So you are getting 22 into 50 into 25 whole square is equal to L into 25 whole square. Okay. Now what will happen? This 25 whole square will cancel this 25 whole square. So you will get 22 into 50 into 25 whole square divided by 25 whole square is equal to L. Cancel, cancel. Now this implies length is 22 into 50. So multiply. So 5 2s are 10. So we'll get this centimeter. Now if you want to change this, then you can change it to meter. In order to convert to meter, you have to divide by 100. So when you divide by 100, you will get 11 meter. Okay. So this is the answer for question number 14. Okay, now let us see question number 15. Here it says a swimming pool 70 meter long, 44 meter wide, 3 meter deep is filled by water issuing from a pipe of diameter 14 centimeter at 2 meter per second. How many hours does it take to fill the bath? Okay, or to fill the pool? So let me draw the figure first. Okay, so this is the figure for question number 15. Here you can see this is your pool. Okay, this is your pool whose length is 70 meter, breadth is 44 meter and height is 3 meter. So this is length, this is your breadth and this is height. Okay, height, fine. And here you can see this is the pipe. Okay, so water is being filled using this pipe. Okay, further they have said that (2 meter), okay, water contained in 2 meter long pipe having radius, this radius, diameter they have given, this diameter they have given to be 14 centimeter. Okay, so they are saying that water contained in a pipe whose length is 2 meter and diameter is 14 centimeter gets emptied in 1 second. Okay, means volume of water contained in this cylindrical pipe whose length is 2 meter and diameter is 14 centimeter gets emptied in 1 second. So they are asking how much time will it take to fill this pool whose length is 70 meter, breadth is 44 and height is 3 meter. Okay. So let us see. So solution. Given for the swimming pool. For the swimming pool, length is given 70 meter, breadth is given 44 meter and height is given 3 meter. And for the pipe, diameter is equal to 14 centimeter. So this will be equal to, your radius will be, therefore radius will be 7 centimeter. And if you want to convert this into meter, you have to divide by 100, so you will get 0.07 meter. Okay, radius in meter is this much. And what they have said is, and water or volume of water contained in 2 meter long pipe gets emptied in 1 second. Okay, so we have this much information with us. Now question is, how much time will it take to fill the pool? So we'll write, suppose t seconds taken to fill the pool. Now here is saying that we are saying that t seconds taken to fill the pool. Okay, so now we'll write volume of the pool will be equal to volume of water in 2 meter long pipe into T. Okay. Now why did I write this equation? Because here they have said that volume of water contained in 2 meter long pipe gets emptied in 1 second. Okay. So since t seconds taken to fill the pool, so therefore total volume of water emptied by that pipe will be volume of water in 2 meter long pipe into T. Okay. Now we will make T as subject. So I can write T is equal to volume of the pool upon volume of water in 2 meter long pipe. Let me write again. Volume of the pool upon volume of water in 2-meter long pipe. And here this T will come in seconds, okay. So let us substitute the values. Volume for the pool means length into breadth into height. So length into breadth into height, and volume of water in 2-meter long pipe. So here this is the pipe, this is the pipe, this is the pipe, 2-meter, and here diameter was 14 centimeter, so radius will be 7 centimeter, and in meter this will be 0.07 meter. So volume of water in 2-meter long will be given by this formula, pi r square h. Here h is this length 2 meter, okay, and r is 0.07 meter, and pi we will write 22 by 7. So here I denote this pi r square, and for this h, no, I'll just write capital H, okay. So now substitute the values. So length for the pool is 70 meter, breadth is 44 meter, and height is 3 meter, okay. And here 22 by 7, r will be 0.07 squared, and here height means this 2 meter. Now we will simplify this. So this 7 will go in the numerator, so we get 70 into 7 into 44 into 3, and here 22 into 0.07 into 0.07 into 2. So 22 1 ja and 2 ja, then 2 1 ja, 1 ja, and here 0.011, okay, and here 0.01 and 10. So 10 into 3, and here we are getting this 0.01 into 0.01. So this can be written as 10 into 3, and here 0.01 can be written 1 upon 100, 1 upon 100. So we'll get 10 into 3 into 100 into 100, okay. So we are getting 3 and here 5 zeros seconds, okay. So t came this much. Seconds. Now we will convert this into hours, okay. So in order to convert this into hours, we will write, we have to divide by 3600, okay, hours. Now here 0 0 cancelled, okay, and then 6 5s are 30 and 2 zeros, and 6 6 are 36, okay. So we got 500 upon 6. Now again we can divide by 2, so done. And then we cannot divide it any anymore, so we will convert this into mixed fraction. Okay, so 25 and here 0. Okay, 3 8s are 24. Okay, 3s are remainder 1, so we will get 83 1 upon 3 hours. Okay, so it will take 83 1 by 3 hours. You want to convert this into minutes, then you can convert this. Okay, so this is answer for question number 15. Okay, now let us see question number 16. What length of solid cylinder 2 cm in diameter must be taken to be cast into a hollow cylinder of external diameter 12 cm, 0.25 cm thickness and 15 cm long? So the question is, if I take a cylinder, okay, whose diameter is 1 centimeter, okay, whose diameter is 1 centimeter, and I want to transform this to a hollow cylinder. I want to transform this to a hollow cylinder whose length should be 15 centimeter, whose external diameter should be, means this length should be 12 centimeter and thickness 0.25 centimeter. So from a solid cylinder I want to transform to this hollow cylinder. Okay, so for the hollow cylinder they have given you the diameter 1 centimeter. The question is, what should be the length of that solid cylinder, okay, which should be used to transform to hollow cylinder. Okay, so I think I should draw the figure once, then things will be more clear to you. So let us see the figure first. Okay, so this is the figure. This is the solid cylinder, okay, whose diameter, sorry, I think its radius is given, diameter is given, okay, diameter is given 2 centimeter, diameter is given 2 centimeter, therefore radius will be 1 centimeter. So this is solid cylinder whose diameter is given 2 centimeter, height is not given, and this solid cylinder should be transformed to a hollow cylinder, means you have to recast this, okay, to a hollow cylinder. Using the same, you have to make now hollow cylinder. So obviously the volume will remain same, okay, volume will remain same. The only thing is, here this will be hollow and its length will be different, okay, it will be of different radius. So that hollow cylinder should have length 15 centimeter and the external one, external diameter is 12 centimeter, okay, and this thickness is given to be 0.25 centimeter, okay. Now the question is, what would be the height of that solid cylinder? So it's easy. The main concept is that volume will not change, shape is changing, volume will not change, okay. So let us see. Here I will write solution for solid cylinder. Whatever we have, we'll write it down, okay. So for solid cylinder, let me denote height by h1, we don't know. Diameter, let me denote by d1, that we know it's 2 centimeter. Therefore radius, let me denote by r1, it will be 1 centimeter. So we know this much, and for hollow cylinder, let me denote height by h2, it's given 15 centimeter and external diameter, so external diameter is given to be 12 centimeter. Okay, therefore external radius, let me denote by capital R1, that will be half of this, that means 6 centimeter. Next, thickness is given, that is 0.25 centimeter. Okay, like here you can see in this figure, this thickness is given, okay, and this external diameter was given. So that's why I was able to write the external radius, half of this 12, so 6 centimeter. Now what would be this internal radius? Internal radius will be external radius minus this thickness. Okay, so thickness is this, therefore internal radius will be external radius minus thickness. Okay, so 6 centimeter minus 0.25 centimeter, so you will get 5.75 centimeter. Okay, now all the informations are written down. We have to find h1, height of the solid one. So now volume of the solid cylinder equal to volume of the hollow cylinder. Okay, so solid cylinder, what is the formula? Pi r square h. Yes, so here r is r1 and h is h1, and for the hollow you know that pi, then height h2, then external radius square minus internal radius square. So external is capital R1. Here denote the internal by, okay, internal radius denote by capital R2, capital R2. So minus square of the internal radius. So you can see that pi cancel, you are left with R1 square into H1 H2, and here R1 square minus R2 square can be written as R1 plus R2 into R1 minus R2. Okay, now substitute the values. So here R1 is 1 centimeter, so you get 1 square, and H1 we don't know. Here H2 is 15 centimeter, R1 is 6 centimeter, and R2 is 5.75. 6 minus 5.75. So H1 will be 15 into 11.75 into 0.25. Okay, so we have to multiply this, and after multiplication we will get 44.0625, okay, centimeter. So this was your question number 16. Okay children, so with this your exercise on cylinder gets over. Okay, so we had decided to do cylinder for the first term, so cylinder is over now. Okay, in the next class we will see next topic. Okay, maybe we will start the similarity. Okay, and the remaining topic on these three-dimensional solids, I mean to say cones and sphere, will be done for the second term. That means after summer vacation we will start. So for the first term we had decided only till cylinder, so cylinder is over. Okay. There are many more questions. If you may try them, and if you get stuck anyway you can ask. Okay.